Okay, let's take a look at example 2.6. And what it says here is that how far did the car in example 2.5 go while coming to a stop? So if you remember from example 2.5, we had a car that initially was moving at 30 meters per second. So its velocity was 30 meters per second in a particular direction. Okay. But it was, you're hitting the brakes. So the acceleration was in the opposite direction. So when it's in the opposite direction, we say it's negative 6 meters per second squared. That's your acceleration. And then what we did was we calculated how long it took for the car to come to a stop. And that was 5 seconds. Okay. So now the question is, how far did the car in this example 2.5 go while coming to a stop? So the distance traveled, if you don't have any initial speed, so if you're starting from rest, is just 1/2 AT squared. 1/2 times the acceleration times the time squared. But if you have an initial velocity, so if you're not at rest, so you have an initial velocity or speed, we can use that term here, then there's an extra term, which is the distance that you travel due to that initial velocity, which is that velocity times the time elapsed. And then you just add that to the second term, 1/2 AT squared. Okay, so you have one term due to the initial velocity, and you have one term. When I say a term, I mean this is a term, this is a term in this equation. One is due to the initial velocity, the other one is due to the acceleration. Okay, so all we got to do is put those numbers in there. The initial velocity was 30 meters per second. So the distance traveled would be 30 meters divided by seconds. The time that we traveled was 5 seconds. And then we add that to the second term, 1/2 times -6 meters per second squared. Remember, the acceleration is in the opposite direction of the motion. So it's -6. And then we multiply that again by the time squared. Okay, so when you do that, you get the seconds divided by seconds cancels, and you just have meters here. So you have 150 meters. And then you have a -75 meters. Okay, notice the dimensional analysis, again, units. You have seconds squared, but you have divided by seconds squared here, so they cancel, right? So it's 1/2 times -6, which is -3. Right, times 25 squared, I'm sorry, times 5 squared, I'm sorry, I jumped ahead. The time is 5 seconds, my apologies. Okay, so 5 squared, so that's 25, 5 squared is 25. So 25 times 1/2 times -6 is 75 meters. Okay, -75 meters. So you're going to add 150 and -75. And so the distance traveled is 75 meters, right? Because 150 minus 75 is 75 meters. Okay. Now, why negative here? Because the acceleration is slowing the car down, right? So it's not going to travel as far as if it were continuing to go. If you didn't hit the brakes and you just traveled at 30 meters per second, you would just go, hey, every second we're going to go 30 meters. Okay. So after 5 seconds, you would go 150 meters, but we're slowing it down. So since you're slowing it down, there's got to be in that equation, there's got to be some term that represents the slowing down, and that's the acceleration. So this -75 is essentially saying, yeah, you would have gone 150 if you hadn't hit the brakes, but because you hit the brakes, that's going to slow how far you're going to go. It's going to reduce the distance that you're going to travel, so it goes down to 75 meters. Okay.